In Lesson 6.4, we're going to solve absolute value equations and inequalities. And if your equation or inequality has a negative number on the non-absolute value side, your answer is automatically no solution. Because remember, absolute value means distance. And you can't say I live -5 blocks from school. That just sounds weird. So you can never have a negative distance. So you automatically say no solution. However, if it doesn't equal a negative number, then to solve them, you're going to remove the absolute value bars and set up two equations. One equation is going to equal a positive number, and the other one is going to equal a negative number. You're going to solve both equations separately and just state your two answers. So let's try this. Here are a few examples. Okay, so first thing we're going to do is remove the absolute value bars and set up two equations. So one is going to be x minus 5 equals positive 3, and the other one is going to be x minus 5 equals negative 3. Now I just solve these two equations. Add 5, and I get x equals 8, and x equals 2. These are both your answers. You're going to have two answers. Okay, so let's try the next one. Okay, again, remove the bars. 5x minus 1 equals a positive 4, and 5x minus 1 equals negative 4. Now it's okay that I have a negative number here because I put that negative number in. I've also removed the absolute value bars. So now I'm going to solve. Add 1. 5x equals 5, divide, and x equals 1. Add 1. 5x equals negative 3, divide, and x equals negative 3/5. So you're going to get two different answers. They're not going to be the same number, so don't just say, oh, I got x equals 8 over here, the other answer is going to be negative 8. That's not how it works. You will get two very different answers. Now in the last one, the absolute value of 4x plus 5 equals negative 1. As soon as you see a negative number over here, you say no solution. You can also put the 0 with the slash if you'd like. What? My slashes are no good. Oh, okay, there we go. Okay, so either of those is acceptable. Now let's try some inequalities. All right, again, we're going to have two answers. But this time, when we do the negative inequality, okay, so we're still going to set up two inequalities. Oops, let's change that. Okay. So we're still going to have two inequalities, one that equals a positive number and one that equals a negative number. But when you do the negative one, you need to flip the inequality symbol for whichever one you change to the sign. So let's try the first one. I'll do x minus 12 is greater than 6, and x minus 12, flip my symbol for the negative one. Okay? So now I solve this. Plus 12, I get x is greater than 18, plus 12, x is less than 6. Now you need to state your answer as a compound inequality, and you're going to graph your solution. So I have to think about this. Can x be greater than 18 and can it be less than 6, or does it have to be one or the other? A number line is a lot easier to figure that out. Now I sort of ran out of room. So I'm going to have to make my writing disappear for just a second, but I'll fix it. Let's give myself a little bit more room. Okay. So bring that all back real quick. That was, whoa, what happened there? Oh, whoa. Oh, no, that was right. Okay. And here I had 18. Okay, so for me it's easier if I do the number line first. Both numbers are positive, so I'm going to do it this way. Shift my 0 to the left. 6 gets an open circle, and so does 18. Greater than 18 is this way, less than 6 is this way. So because when I graphed it, I got arrows that pointed in different directions, I know that my answer is going to include the word or. Okay, so I'll give you an example where it won't be an or. Actually, that doesn't seem to happen in any of these. Okay, I'll have to make up an extra example. But in this next one, hopefully you look at this next one and you can immediately see, uh-oh, I have a negative number over here, so I don't even do any work. I just say no solution or 0 with a slash. Don't even do anything. All right, and then we give you one over here that's got fractions. And what we can do here is let's change this one. Let's change this to be a less than or equal to, and that'll help us here. So set up your two inequalities. 4/9 minus t is less than or equal to 2/3. And 4/9 minus t is greater than or equal to negative 2/3. Remember to flip the symbol on the one that has the negative number. So now I go to solve this. Subtract 4/9. Negative t less than or equal to, that 2/3 becomes 6/9. So 6/9 minus 4/9 is 2/9. Change my sign, which is really dividing by a -1, so I have to flip my inequality symbol. T is greater than or equal to -2/9. And in the other one, I'm going to change my color because it's getting a little hard to look at over here. Let's go with a purple. Subtract 4/9. And I get negative t greater than or equal to. Now both of these numbers are negative. So this time when I have negative 6/9 and negative 4/9, it's negative 10/9. Divide by -1, flip my symbol, and I get positive 10/9. Okay, again, I'm going to have to scroll up so I have room, which all this writing is going to disappear. So if you need to pause this video to copy that down, do so, and then you can catch back up. All right, so I'm going to scroll down. Okay. So now for this one, my two answers were, whoops, I didn't write the other one down. T is greater than or equal to -2/9. Oh, and t is less than or equal to 10/9. That's what it was. Okay. So now these are both fractions. So we don't need to be super nitpicky about where they fall, because one's positive, one's negative. So here's 0. -2/9 is less than 1, so he'll be pretty close to 0. 10/9 is bigger than 1, so we'll put him over here. Both have closed circles. Now, greater than -2/9 would mean to go to the right, and less than positive 10/9 would mean to go to the left. So because my arrows are going to face each other when I do this, whoops, don't do that. Okay, because my arrows face each other, I need to write this as a compound inequality. And you're always going to put small number, less than x, less than big number. And you'll include the equal to if you need to. So the smaller of my two numbers is -2/9. Less than, now this had a line underneath it, so I'm going to put a line. My variable was t. But the same symbol, this one also had a line underneath it, and your bigger number. So when you graph it on a number line and your arrows connect to each other, you have to write your answer as a compound inequality. You may not write your answer as two separate inequalities. So graphing it is a good way to figure out if you need to write it as one compound inequality or if you get to write it with the word or, like we did in the first example. And there is 6/4.